Hello, welcome to our video for 3.3, solving systems of equations in three variables. Okay, our systems are getting larger, so you can expect the work to take up a lot more space. Okay, take notes, use the closed captioning if necessary, and have your phone ready in case you need to message me any questions that you have. Okay, so 3.3, solving systems of equations. Solving systems of equations in three variables. So what do I mean by that? So I'll give you this example and we'll do this one last, okay? So instead of x and y, now you have x, y, z. So maybe you have a system that looks like this: 2x plus 3y plus 4z equals 18. And so now we have three variables. So we'll need three equations: plus 4y plus z equals 1, and x plus y plus 3z equals 13. Okay, so this would be a system of three equations, three variables. Okay, so what happens here is we're going to be using elimination method. And so when it comes to solving, there's definitely a process. So the first step you want to do is choose two equations. So you have three, right? So you would choose two equations and eliminate a variable of your choice. Okay, so choose two equations, eliminate a variable of your choice. Okay, and you're going to use a elimination method. Okay, and you're essentially going to be doing this twice, this first step. Okay, so step 2, repeat. Repeat step 1. But you're going to use two other equations. So let's say you chose in step 1 you chose these two. Well, then in step 2 you repeat that, but you choose two other ones. So maybe I choose these two instead. Okay. Which ones you choose, it doesn't matter, so long as the first round you do 2, the second round you pick a different 2. Okay. All right. So what happens is when you eliminate a variable and you whichever variable you chose here in step 1 to eliminate, over here you also have to eliminate that same variable. Okay. So make sure you eliminate same variable chosen in step 1. Okay, so here in your first choice here, if you chose to eliminate x's, when you do it the second time, you have to also eliminate x's. Or if you, in the first step, if you chose to eliminate z's, then in your second step, you also still have to eliminate z. So whatever variable you choose to eliminate, you're going to do that twice. Okay. So what's going to happen is here we have three variables. And what we're doing here by eliminating one of the variables is we're basically reducing this system into a system of two equations, which is what we learned in the previous sections, right? Where you only had like the x and the y, right? So if you kind of erase all of this right here and you only have these four. So that's what we're essentially trying to do. Okay, we're trying to reduce this down to a system of two equations, which is what you're familiar with. Okay, so the resulting equations in step 1 and 2 form a smaller system of two equations, which is what you are familiar with. Okay, solve this system. Okay, when you solve this system, you will have the solutions to two of the variables, and so you will need to solve for the third one in this last step. And if you have two, you should be able to solve for the third. Okay, so let's go ahead and do an example where we put all of these steps into action. Okay, so let's take a look at this one. Let's go ahead and solve 2x minus 3y plus 2z equals negative 7, x plus 4y minus z equals 10, and 3x plus 2y plus z equals 4. So I must say that this, because the process is very long, there's lots of room for error. And I would say most mistakes that students make is not so much from lack of understanding, but small calculation errors. Okay, so just be careful, double check your work. Another place where a lot of errors occur is right from the very beginning, copying the problem incorrectly. Okay, so that's also one of the common mistakes, and sometimes we'll be sitting there going over the student's work, looking at it, and nothing is wrong, and then we realize, oh, you copied the problem incorrectly. Okay, so that very first step, it says to choose two equations and eliminate a variable, and then choose another two equations and eliminate the same variable. Okay, so again, it doesn't matter what you choose at the very end, everybody will come up with the same answer. Okay, so I'm going to go ahead and choose to eliminate z, since when I add these two, they're going to eliminate anyway. Okay, so I'm going to, and again, we're going to do that twice, right? So here's step 1, and I'm going to use number 2 and 3, and I'm going to eliminate z. All right, and then step 2, I have to repeat that. But I have to pick two other equations. So I will pick numbers 1 and 2. And I will eliminate z. Whatever you choose to eliminate, you have to do that in both of them, okay? So if you choose x here, you have to choose x here, okay? All right, so I'm going to choose 2 and 3. So these two, equation 2 and equation 3, to eliminate the z. So let me go ahead and write that down. X plus 4y minus z equals 10. 3x plus 2y plus z equals 4. Okay, I am just double checking to make sure I copied the problem correctly, and I did. Okay. All right, so here I'm going to go ahead and eliminate the z. Okay, when I add these, and I get 4x plus 6y equals 14. And over here, I'm using number 1 and 2, so these two to eliminate z. 2x minus 3y plus 2z equals negative 7. X plus 4y minus z equals 10. All right, so right off the bat, the z's do not cancel out. They don't eliminate. I need to multiply this by 2. That way I'll have 2 and negative 2. All right, so let me go ahead and multiply this entire equation here by positive 2. Okay, so then the first one remains the same. And the second one becomes 2x plus 8y minus 2z equals 20. Now the z's will eliminate. Okay, so again, if you eliminated z here, you have to eliminate z here. Okay, so when I add these two equations here, the z's do get eliminated, and I get 4x plus 5y equals 13. Okay? All right, so what happens here is, so now we end up with these two equations, right? So here, this one and this one forms our smaller system. So let's go back to those steps. Okay, so we did 1 and 2. We chose two equations, eliminated z, and we did that twice. It says here the resulting equations in step 1 and 2 form a smaller system of two equations. Solve this system. Okay, so when you do this, you end up with an equation here and you end up with an equation here. And so what happens is this is your smaller system. So you have to solve this system. 4x plus 6y equals 14. 4x plus 5y equals 13. Okay? And we all know how to use the elimination method from the previous section. So I can go ahead and eliminate this, but I need to multiply this one by negative 1. Okay? So let's do that. Okay, so I need to multiply this one by negative 1. Okay? And so let me go back to black. Okay. So then the top equation remains the same. The bottom one becomes negative 4x minus 5y equals negative 13. And now these will eliminate, and I get y equals 1. And now I can go back into my smaller system and solve for x. I'll use the first equation, 4x plus 6 times 1 equals 14. So 4x plus 6 equals 14. 4x equals 8. X equals 2. Okay, so far I have two answers. I have x and y. I need to solve for the third variable. Okay, so let's make sure we understand what's happening here. So you started off with this system of 3 equations, right? We do that step 1 and step 2, which are very similar. You choose two equations, eliminate a variable. Choose two equations, eliminate the same variable. And what happens is when you eliminate that variable, you end up with this two variable equation. And these two results form that smaller system. And we know how to solve this from the previous section. Solving this system, we found x equals 2, y equals 1. Okay, so this part right here should be familiar. How we get this is from the first two steps. Okay, once you know two variables, you can go back to the very original problem and choose any of those three equations and plug in for x and y to solve for z. Okay, so I will choose this third equation. Again, it doesn't matter which one. Okay, x plus 2y plus z equals 4. Let me do that over here. So x plus 2y, okay, my short-term memory is bad. X plus 2y plus z equals 4. Hold on. 3x plus 2y plus z equals 4. 3x plus 2y plus z equals 4. Okay. All right. So I'm going to use that one. So I'm going to plug in 2 for x and 1 for y, and I should be able to solve for z. So 3 times 2 plus 2 times 1 plus z, we don't know. So I get 6 plus 2 plus z equals 4. 6 plus 2 is 8 plus z equals 4. Subtract 8 on both sides, and I get z equals negative 4. Z equals negative 4. So now I have all three coordinates. So my answer, alphabetical order, x, y, and z. This would be the final answer. And again, we can always check to see if our final answer is correct by plugging in 2, 1, and negative 4 into all three of these equations to see if we get these answers over here. Okay? All right. Let's go ahead and try that very first one. Okay? So let's see. All right, let's try this one. Solve. Suppose we have 2x plus 3y plus 4z equals 8. No, 18. Okay, 18. 3x plus 4y plus z equals 1. X plus y plus 3z equals 13. Okay, so I will choose to eliminate. X's. Okay, so that's what I'm going to do. All right, so step 1. Okay, so step 1 and step 2, right? Okay, so we're going to eliminate the x's. So I will use the first one and the third one. Again, it doesn't matter which ones, so long as you eliminate. I'm going to eliminate x, And then for my second choice, I will use number 2 and 3. Number 2 and number 3. And again, eliminating x. Okay, so over here, so let's go ahead and copy down over here. I'm going to bring down number 1 and number 3. So 2x plus 3y plus 4z equals 18. And number 3, which is x, plus y plus 3z equals 13. Okay, so I need to, if I'm eliminating the x's, I want this to be 2x and negative 2x. So I need to fix that second one by multiplying everything here by negative 2. Okay. All right, so that first one remains the same. 2x plus 3y plus 4z equals 18. And that second one becomes negative 2x minus 2y minus 6z equals negative 26. All right. Ooh, where did the negative go? Oh, there it is. All right, so this will work now. My x's get eliminated. So I get 1y minus 2z equals negative 8. Okay, now let's do the other side, this one. All right, so we picked 1 and 3, so now we'll do number 2 and 3. Again, it doesn't matter which 2 you pick so long as it's different from the first set. All right, so number 2, let me go ahead and bring this down. And number 3, okay. And let me just make sure I copied everything correctly. Okay, good. All right, so I want to eliminate the x's, so I need this to be negative 3. So I need to multiply that entire equation, this one, by negative 3. Okay. All right, so the top one stays the same. And the bottom one becomes negative 3x minus 3y minus 9z equals negative 39. Okay. So then now these cancel out. And we're left with y minus 8z equals negative 38. All right. So you can see here there's a lot of computations going on, lots of room for small mistakes. Okay. All right, so now we have our 2 equations right here. So our 2 equations here form our smaller system. Y minus 8z equals negative 38. Okay, so we could use elimination method. Let me fix this. This looks weird. Okay, so that's supposed to be a z. Okay, all right, so we could use elimination method. I could eliminate the y's. I need to make this negative. Okay, so let me multiply this by negative 1. Okay, so remember this system came from these 2 equations. Y minus 2z equals Ooh, I didn't copy that one right. Negative 8. And y minus 8c equals negative 38. Okay. All right, so top one remains the same. Bottom one becomes negative 1y. Positive 8z equals positive 38. Okay. So now the y's. You could easily use a substitution method as well. That's fine. Either method will work. And so here I get z equals 5. So I have one of my variables. All right, so I'm going to I'll use the top one to solve for y. All right, so I'm going to substitute 5 in for z to solve for y. So y minus 2 times 5 equals negative 8. Y minus 10 equals negative 8. Add 10 to both sides, and I get y equals 2. Okay, so I have 2 of my variables solved. And again, to get the third one, you have to go all the way back up to where you have the third variable. Okay, so I'm going to use, what did we solve for? Z and y. All right, so I need to solve for x. I'm going to use this third equation down here. X plus y plus 3z equals 13. All right, so x plus y plus 3z equals 13. Okay, so I'm using that third equation. X I don't know. Y is 2 plus 3 times 5 equals 13. So all I did was take this y and z value and plug them in right there and there. Okay. So x plus 2 plus 15 equals 13. X plus 17 equals 13. X equals negative 4. Okay, so x equals negative 4. So we have all 3 answers. So now I can write it as a point alphabetical order: x, y, oops, hold on a second, x, y, and z. And that would be your answer right there. Okay. All right. Again, if you have any questions, make sure you message me, make sure you email me, get in touch with me somehow. Okay. So that's it for solving systems with 3 equations, 3 unknowns. I'll see you next time.